Hi, in this video we are going to talk about inverses. There's two main objectives. We're going to see if we can figure out inverse relationships in the form of tables and graphs. And then we're also going to look for and use the line of symmetry, so the equation y equals x, to verify inverses of both equations and graphs. Two other things to know about inverses. We can find inverse functions by just switching the x and the y values. And then our focus for today is how we can check our answers by looking for symmetry in the graphs. And that line of symmetry, again, is going to be the equation y equals x. So first thing, how do you create an inverse table? Well, here's an example of a couple of tables, and we're going to try to come up with the inverses. All you have to do to figure out an inverse table is switch the x values and the y values. So if you look at this first example, where we have the yellow background, the first thing that I'm going to do is just switch the x's and the y's, or in this case, switch the x's and the g of x's. So I'm just taking my g of x values and putting them as my x values instead. And then I'm going to take my x values and make them my inverse g of x values. So I'm just switching my two columns around. I'm going to do the same thing for this other table, the one that we have here in purple. So I'm going to start by making my h of x values my x values. I am going to have them go from lowest to highest so that we can hopefully start to see a pattern. So I took these h of x values and put them under x. The only other thing I changed was just going from lowest to highest. And then when I match up my x values and turn them into my inverse h of x values, I just need to make sure that I'm matching things up appropriately. So for example, this -5 was next to 15, so I just make sure that I put the 15 next to the -5. All right, so here's a challenge question. Can we figure out what the equation would be for the inverse of h of x? What I would do is look for a pattern in the table. So if you look at your y values, it looks like they're just going down by 1. And if you look at your x values, it looks like they're going up by 5. Since that's consistent, they keep adding or subtracting the same amount, we must be looking at a linear equation. So our slope would be -1/5. Since we're going down by 1, we have -1. And then that's our rise, and then our run would be up by 5, so our slope is -1/5. The y-intercept is given to us in the table. It's at 0.14. So now we can write the equation y equals -1/5 x plus 14. All right, so that's how you do tables. Now let's look at how you do graphs. So again, what we're going to do is switch the x and the y coordinates. What I would suggest is that you make a table where you list your x values from the left side of the graph over to the right side of the graph. So you're going to go from lowest to highest for your x value. So I'm going to start with this point here, this -4, -2. So I've got -4, -2. That connects to -2,9, and then that connects to 4,7. Connecting them in the order that the graph is drawn is important. Now let's make the inverse table. So I'm just going to switch my x's and my y's. So now I've got the point -2, -4, 9, -2, and then 7, -4. And I'm going to go ahead and graph those. So I have those graphed over here in purple. One of the things that I want you to notice is that these two graphs are symmetrical to each other, and they're symmetrical over the line y equals x. So y equals x is represented by this dotted orange line. Since we're switching the x and the y's, the equation y equals x is where they're symmetrical. So these 2 points match up, these 2 points match up over that line, and these 2 points match up over that line. If you were to draw in lines connecting those points together, you would notice that those lines are perpendicular to your line of symmetry. So there's a right angle for all three of these. That's a great way to tell that you did make your graphs so that they are inverses of each other, is when they're symmetrical to each other. I'm going to show you just a couple of other graphs. So here's another example of two graphs that are inverses of each other. We've got the equation for the line y equals 3x plus 2, and then we've got the equation for the line y equals x minus 2 over 3, and you can see that these two are symmetrical over this red dotted line this time. So they are symmetrical over that. One other thing I'd like you to notice is when these 2 points cross that red dotted line, if you look at the ordered pair there, it's -1, -1. They should only meet in spots that have the same x and y values, where x and y are actually equal to each other. Let me show you an example of a couple parabolas. So here's an equation for a parabola. The blue parabola is y equals x minus 2 squared minus 6. And then the other parabola is a sleeping parabola. And you can see that these are inverses of each other as well. They are symmetrical over that line, y equals x. You might also notice that if you look at the vertex of each of these, they are inverses of each other. So we've got one vertex at 2, -6, and we've got the other vertex at -6, 2. The x's and the y's are switched. One last graphing example, just to show you another shape. Here we've got just a couple of half parabolas, and if you look, these are symmetrical to each other over that line y equals x. If you look at their starting points, you've got the point -2, -3, and you also have the point -3, -2, so you can see the x's and the y's are switched. Another nice point that you could check and see is your intercept. So we have one intercept at 7, 0. We have another intercept at 0, 7. The x's and the y's are switched, so they are inverses. The last thing that we're going to look at is how you can determine function values if you're looking at a table. And this would work the same way as if you're looking at a graph. So here I've got two different tables. I've got one equation for f of x, one table for the equation f of x, and then I also made the inverse table over on the right-hand side here. We're going to see if we can calculate f of -2, and then also what x would equal for f of x equals -2. So since we're looking at the f of x equations, I'm going to use this table over here to determine the value of f of -2. I'm just going to find -2 in my table, and I can see that my f of x value is -5. For the next one, I'm going to try to figure out when f of x is equal to -2. So I'm trying to find -2 in the f of x column, which shows me that my x value would be +2. Last two examples are what if you need to figure out what the inverse function would be for 3, or if you're trying to figure out what x would be for your inverse function equal to -3, or equal to +3, I should say. So for f of -1 is equal to 3, I am going to use this table over here because it's asking me about the inverse function, and this is the table for the inverse function. I'm going to find 3 in my table and figure out that my inverse of f of x value would just be 1. And then finally, I'm going to try to figure out what x would equal if I know that the inverse of f of x is equal to 3. So I'm going to try to find 3 in this column. And if I do that, I can see that my x value is 8. So there's a summary of inverse relationships from tables and graphs.